Hello everyone, in this video we're going to be solving a system of equations. At this point you can just go ahead and pause the video and try the problem yourself first. Okay, so we have x squared plus 2y squared plus 3z squared is equal to 36. 3x squared plus 2y squared plus z squared is equal to 84. xy plus xz plus yz is equal to -7. And we're looking for real solutions. Okay, alright, so let's get started. First of all, I'm just going to go ahead and number the equations to make it easier to refer to them. So what I'm going to do is I'm going to call this one number 1, call this one number 2, and call this one number 3. Okay, so I'm going to go ahead and add 1 and 2 first. Okay, when I add those two equations, I'm going to be getting 4x squared plus 4y squared plus 4z squared is equal to 36 plus 84, which is 120. If I divide both sides by 4, then I'm going to be getting x squared plus y squared plus z squared is equal to 30. Let's call this equation 4. So now we have 4 equations. Now, since we know x squared plus y squared plus z squared, we can actually go ahead and use 3 and 4 together. And we're going to be getting the x plus y plus z quantity squared from here, because that's equal to, as you know, x squared plus y squared plus z squared plus 2 times the quantity xy plus xz plus yz. So from here we get x plus y plus z quantity squared is equal to, we know that x squared plus y squared plus z squared is 30, and the sum of two-way products is going to be -7. So this is going to be 30 plus 2 times -7. And that's equal to 16. Okay. So now we have two cases because there are two numbers whose square is 16 basically. And remember that we're looking for real solutions here. So case 1. Let's just call this case 1 in Roman numerals. And let's just say that x plus y plus z is equal to 4. That's going to be our first assumption. Okay. So now what does this give us? Well, if we assume that, we can actually go ahead and do the following. We can just simplify. Okay, here's what I'm going to do. I'm going to go ahead and isolate x plus y. Actually, never mind. I changed my mind. I want to go ahead and use the x plus z, because in the next step, I'm just going to get something similar to this. So x plus z is going to be 4 minus y. Okay, so I'm going to use that later. Now, the next thing we can do is from these three equations, if you actually go ahead and subtract 2 and 1, okay, if you go ahead and subtract 2 and 1, you're going to be getting the following. Okay, number 2 is 3x squared plus 2y squared plus z squared, and number 1 is x squared, okay, x squared plus 2y squared plus 3z squared, and that's going to equal 84 minus 36. Okay, now let's go ahead and simplify this. This is going to be 3x squared minus x squared. That's going to be 2x squared. 2y squared is going to cancel out, and then minus 2z squared. That's going to equal 48. If you pull out a 2 there, divide both sides by 2. In other words, we're going to be getting x squared minus z squared being equal to 24. This is why I wanted to isolate x plus z, because now I'm going to factor x squared minus z squared using difference of two squares. Let's go ahead and do that. X plus z multiplied by x minus z is equal to 24. Now, how does this help us? Well, we know that x plus z is equal to 4 minus y. So let's go ahead and replace that. And from here, we're actually able to solve for x minus z. Let's go ahead and isolate that by division. It's going to equal 24 divided by 4 minus y. So now I kind of got like a system of equations for x and z. And suppose y is kind of like a constant at this point. We can actually solve this system, right? So I'm going to go ahead and put those together. So I have x plus z is equal to 4 minus y, and x minus z is equal to 24 divided by that. Okay, now in this system of equations, elimination is fairly easy. We're just going to add these up. Z is going to cancel out. We're going to get 2x is equal to 4 minus y plus this quantity. Okay, so we're going to use some substitution here, additional ones. So what's going to be very helpful here is that if these are actually even, 24 over 4 minus y is going to be even, but let's go ahead and call this quantity 2u. Then this will be equal to 24 divided by 2u, which is equal to 12 over u. The reason why I do that is going to be obvious in the next step, because what I want to do here is I want to add two even quantities so that when I divide by 2, the result is going to be nice. Okay, so I'm going to go ahead and do the replacements and divide both sides by 2, and that should give me x equals u plus 6 over u. Now this is an important result because I was able to get x in terms of u, and I can do the same thing for z. If you actually go ahead and subtract these equations side by side, you're going to be getting the following. You're going to get rid of the x and you'll get 2z is equal to 2u minus 12 over u, and dividing by 2 will give you a similar result, which is pretty good because now I was able to get x and z in terms of u. How about y? Well, in this assumption here, I can easily solve for y, right? Y is going to be 4 minus 2u. So this is pretty good because now I'm able to represent each variable x, y, z in terms of a single variable, which is u. Okay, awesome. Now, what I'm going to do is I'm just going to go back and use equation number 4, which is the sum of the squares. Let's go ahead and use 4 now. So use number 4 and substitute all of these into the equation. Let's see what we get from here. Okay, so we're going to be getting x squared. Let me rewrite 4 so you can see what it looks like. X squared plus y squared plus z squared is equal to 30. Remember, we received this equation from adding the first two equations and then dividing by the greatest common factor. Now, what I'm going to do is I'm going to replace x with u plus 6 over u squared. Y will be replaced with a simpler expression, 4 minus 2u, and z will be similar to x, but it's just going to be the minus version. Okay, and all of this is equal to 30. Now, what I'm going to do is I'm just going to expand it and try to get a good equation from here. Okay, let's see. This is going to be u squared plus 12 because u is going to cancel out, plus 36 over u squared plus 16 minus 16u plus 4u squared plus u squared minus 12. Again, u cancels out, plus 36 over u squared, and all of that is equal to 30. Okay, so let's go ahead and simplify this a little bit more. Nothing cancels out, so I'm going to have to add like terms. U squared plus 4u squared plus 1u squared. That's going to make altogether 6u squared. Okay, then let's just go ahead and add these terms. 36 over u squared plus the same thing. It's just going to make 72 over u squared. So I've taken care of this one and this one. Let's just mark those as we go. And then I have a u term, minus 16u. I think that's just by itself. And then I have my constants. The constants make what? 12 and negative 12. Well, I said nothing cancels out, but I was wrong. These two cancel out. Now I have 16 minus 30, which is negative 14. So everything is taken care of, and this whole thing is equal to 0. Nice. Well, we still have a rational expression. So what we need to do is get rid of all the fractions. So I'm going to multiply both sides by u squared. We know that u does not equal 0, so it wouldn't be a problem. So let's go ahead and do that. 6u to the 4th plus 72 minus 16u cubed minus 14u squared is equal to 0. Let's rearrange these terms to make them a little nicer. Standard form, so on and so forth, right? Okay, so let's make sure we get it right. We have 6u to the 4 minus 16u cubed. Okay, I multiply by, that's a 16u plus 4u squared. Okay, u squared minus 12 plus, okay. All right, so this is our expression after multiplying by u squared. What are we going to do next? Well, we're supposed to simplify this further, but how do we do that? Well, first of all, notice that you can divide both sides by 2. Let's go ahead and do that. 3u to the 4th minus 8u cubed minus 7u squared plus 36 is equal to 0. Okay, now we can't divide anymore, but by using the factor theorem, okay, so we know that if this equation has rational roots, hopefully it does, then we can just compare or look at the divisors of 36 divided by 3. Okay, so 36 divided by 3 is 12. So any rational root must actually, or if there's any integers, then it needs to divide 12. So at this point, it's pretty much trial and error, but I'm just going to save you the trouble for the sake of time. And I'm just going to tell you that u equals 3 actually works. Let me go ahead and verify that here. 3 times 81 minus 8 times 27 minus 7 times 9 plus 36. Now this is 243, and this is going to be 8 times 27 is going to be 216 minus 63 plus 36. If you subtract those, you're going to be getting 37 from here minus 63 plus 36, and 37 plus 36 is going to be 63, and 63 minus 63 is going to be 0. So this verifies that u equals 3 is actually a solution to this equation. Of course, we could find that by trial and error, but I just wanted to save some time here. Okay, after figuring out that u equals 3 is a solution, obviously u minus 3 is going to be one of the factors, and by polynomial division, I'm just going to give you the other factor again to save time. Okay, but you can always verify this yourself. We're going to be getting the following factor. Okay, so now I have a linear factor from which I know that u equals 3, and the other one is cubic. So it has 3 solutions. We don't know how many of them are real. Okay, that one is kind of problematic to solve, right? Because you can use the cubic formula or other methods, but trust me, it's going to be painful. So I'm going to give you that one as well for free. So we know u equals 3. Another solution that comes from here after applying the cubic formula is going to be the following. You're going to get -1 plus the cube root of 1403 minus 18 times the square root of 5919 plus the cube root of 1403 plus 18 times the square root of 5919 all over 9. Okay, so this is going to be another solution that comes from the cubic. What happens with the other solutions? Well, if you look at the other solutions from the cubic, you're going to find out that there are 2 complex solutions which we're not interested in. Therefore, we don't care. These are the only real solutions. Now, what happens with the second case? Let me just kind of tell you what it is. And again, for the sake of time, I'm just going to skip that part. But I'm going to tell you what is going on. Our first case assumed that x plus y plus z is equal to 16. And we said that x plus y plus z is 4. Case 2 is going to be x plus y plus z is equal to -4. Okay. I guess I was using the Roman numeral, so let's be consistent. Case 2 is going to involve the fact that x plus y plus z is equal to -4. And again, from here, you can make the assumption x plus z is equal to -4 minus y. And then using the fact that x squared minus z squared is equal to a given number, you can just go ahead and proceed similarly. And after so many steps, you're going to find an equation that is very similar to this, which is slightly different. And again, I'm just going to leave it up to you to proceed, but I'm just going to give you the equation as a linear factor and a cubic factor. And the solutions, again, are going to be coming from here. Okay, that's it for this video. Thank you very much for watching. Please comment, subscribe, and like the video. Let me know what you think, and see you in the next one. Until then, take care. Bye-bye.